Great. Acho que primeiro que veio foi Natália Traian, certo?
Добрий день.
Доброго дня, пане Богдане. Я ще все це поясню, як переключатися на переклад, але просто скинула для тих, хто приєднається пізніше. Лесь, а ти зараз в цьому чаті чи в перекладацькому? Доброго дня всім, хто приєднався. Зараз ще приєднується наш спікер і трошечки зачекаємо, напевно, на людей, скільки маю пояснити, як підключити переклад. Ми тоді секунду зараз протестуємо презентацію з спікером, і я тоді все поясню. Hi, Joachim.
Nice to meet you here.
To meet you, yeah, at least. If not in person, at least to meet you.
Yeah, maybe next time, hopefully.
Hopefully, yeah, when it all ends. Thank you, first of all, thank you for agreeing to participate. It's very important for us.
It's my pleasure.
You and I will stay on the same sound channel, and our interpreter with our participants will be on the second sound channel. They will listen to Ukrainian interpretation and will stay here. But maybe let's test the presentation. Do you remember how to share the screen? Or maybe you want me to assist?
I tried to do that. That means I just have to, let's say, speak a bit slowly, or I don't have to wait for the translation, right?
No, it's synchronic. Lisa, what are these wishes?
I mean, should I speak a bit slow?
Yeah, just a second. Here's Lisa. Let's change the channel. We can't hear you. No. Could you please, Lisa, we can't hear you. Could you switch off to the main channel? Okay. Just a sec. We have some problem, I guess. And we are on the main. Just a second, I'll call her because it's important for our participants to hear her. Okay, let's first start sharing the presentation and I'll talk to Alyssa.
Okay.
I've allowed sharing the screen, so you have, yeah. Yes, we can see it.
Is it now in presentation mode?
Well, yeah, now it is.
Okay, cool.
Добрий день.
Доброго дня. Just a second. Yeah, Joachim will just test the translation. Пане Богдане, ви мене зараз чуєте?
Чую.
Ага. Ви не могли б все одно, ну, якщо потрібно буде вам слухати українською, потрібна просто допомога, ну, навіть всіх присутніх. Там в нижній панелі, праворуч, є такі 3 крапочки, типу додаткові функції.
Додатково, так.
І
Є
там
перевод.
можна, да, переклад. І потрібно вам обрати українська. І зараз,
Так, я обрав.
Лесь, скажи що-небудь, Бліс.
Чути чудово, дякую.
Добре.
Чути добре, так? Тобто я з Ахімом тоді залишаюся на цій лінії з Ахімом, а всі, кому потрібен переклад, то підключаємося до української версії, добре? Дякую, ну я ще всім поясню, хто пізніше приєднається. Окей, Joachim, can you hear me now?
Yeah, very well.
Oh, great,
Так,
yeah.
перевіряємо, чи чує нас наш мовець.
Ага. Ну, я принаймні чую. Joachim, could you hear Lisa a few seconds ago? Can you hear Lisa? Oh, Joachim, are you here? Oh, hear him?
Yeah,
Can you hear me?
yeah, just you.
Yeah, only me, yeah?
Yeah,
Without Lisa. Mm-hmm. Okay, it's fine. Let it be so because and now?
just hear you.
Can you hear me? Great, because we have 2 channels and there are some problems. It's the first time we're testing the synchronic online translation.
Oh,
And I was afraid of doing it, but anyway, yeah. So maybe I will introduce you to our participants in Ukrainian in the very beginning, and then we'll go the floor to you, and Alyssa will interpret your speech, okay?
perfect.
Thank you. Так, а дорогі учасники, хто ще
Okay,
залишає...
dear participants.
Ні, Лесь, зараз не потрібно перекладати. Є хтось, хто ще не приєднався до перекладу? От зараз на цій основній лінії зі мною. Ага. Всі вже... Окей. Так, дорогі учасники, тобто вже всі приєдналися до перекладу, так? Всі чують зараз цю лінію.
Чуємо, все нормально. Там все зрозуміло, я думаю, розберуться. Що...
Ну, я
Все-
сподіваюся, да, я
да,
просто
да,
намагаюся протестувати, хто де що чує, бо ще люди приєднуються, і я тоді залишусь з Яхімом там. Ну, отже, да, дякую всім, хто вже приєднався, хто приєднується, будь ласка, прошу перемикатися до перекладу, принаймні мене має бути чутно і на тому каналі. Десь гучніше, десь тихіше. Єдине, що хочу нагадати, що запис, який буде, він буде, власне кажучи, з англійською версією. І я вже вам надсилала матеріали, власне, про нашого спікера. Хочу коротко представити, поки що українською. Це Joachim Venus, старший науковий співробітник промислової біотехнології, який саме має диплом з біотехнології від кількох університетів, ступінь доктора філософії з біоінженерії. І, власне, дуже багато займався міжнародною діяльністю. Ми про це також попросили його сьогодні поговорити. Отже, дуже дякую. Я тоді перемикаюся до Joachima. Прошу всіх залишатися, кому потрібна українська версія тут. Joachim, thank you. I've introduced you to our participants in Ukrainian, and now the floor is yours. And please, you can start. We can see the presentation. Thank you for participation in the project, and thanks to the US Embassy in Ukraine. It was possible to start implementing this project. So thanks to the embassy as well.
Okay, thank you very much, Oksana, for the nice introduction, and thank you all for being here with us today. And first, I have to admit that, of course, it's not that easy for me to talk in such a, times what we have since more than 2 years. And as you can imagine, I don't have really a post-war experience in order to talk about my research or also the connection to the industry, to the business. So that's just impossible for me, as you can understand. But anyway, we have discussed with Oksana in advance, and it would be possible to talk about that, what we do here in Potsdam at our institute. And I hope it might be in a way interesting for you, despite the terrible situation right now. So actually the question was if someone could talk about agriculture and energy. As you can see from the title, it's partly agriculture, since unfortunately, sorry for that, the logo of our institute is just in German. That means we are a public research institute for agricultural engineering and bioeconomy. And in this sense, of course, agriculture, bioeconomy, energy, products, feedstocks, and so on and so far are somehow closely together. And I hope I can give you some insights in that, what we do and we did already for the last decades. And of course, I would be very happy if that could contribute in any way to a situation after the war, what we do hope, which is not that far from today. So that's just as a short introduction and give you an idea about that, what I was feeling getting this request to give a talk about this topic. Now I cannot change the slides, obviously.
Oh, yeah, just on your screen, on your computer, not in Zoom.
Can you see the second slide?
Yes, we can.
Okay, perfect. Sometimes this doesn't work. So just a brief introduction to our institute. As you can see here, it has a long history in agricultural science and agricultural engineering. And right now, the new building right bottom, where, by the way, my office is, if you see my cursor, my office is just here. So I am at this moment behind these windows. And the weather is also like this. It's sunny, it's going to get spring, but this is not the topic of today. I just like to give you some insights about that, what we are doing. So the institute is about 290 staff members, depending on the projects ongoing, and it could vary between 250, 300 something, things like that. Of course, we are dedicated to young scientists, try to promote the development of the young scientists here. We have, compared to many universities, an excellent infrastructure, which is not only with laboratories and some devices, things like that. We have really relatively huge pilot plants, what you can see in the back of my picture. That's a view into our pilot plant, where I will come back in a few minutes, and also some experimental areas outside what you probably could expect from an agricultural directed institute, with some fields and things like this. So we try not to stop with the basic research in the lab. We try to go up in the scale. That means we have to bridge the so-called Valley of Death, which is, in the sense what I was talking in the very beginning with that war at the moment. It sounds a bit crazy if we are talking about the Valley of Death in the sense of science, but it is a phrase which is very often used from the community. We have huge international networks in all parts of the world, for sure, and since the talk today should address some aspects of the connection between science and industry application, so we have a lot of practice in that way, and I hope to give you some examples of that. So just a few figures about our funding, which is in the range of about 15 million euro, and then besides that, we try to earn approximately 30-35% of that budget by so-called third-party funding, different projects, bilateral agreements with the industry, things like this. So just briefly, our content, the program areas, what we call, it's what everybody could expect from an agricultural engineering institute. It has to do with crop production, it has to do with livestock production, with animals, and of course, everything's, or nearly everything from the crop and the animals ends up in the food area, the manufacture of food in different issues and approaches to make the food more healthy, more stable, something like this. And then during the last years, we realized that not all of our scientists are working in that field of finally producing food and feed products, but we are also working in the so-called non-food area, which we nowadays describe with that area multifunctional biomaterials and with the integrated residue management. In my working group, which has a title bioconversion, that means that we are in the more or less direct connection between the two areas, since we try to use as much as we can those residues in order to feed our processes to make chemicals and biomaterials out of it. So that means the area of using crops and commodities like sugar and starch, what we did, let's say 20 years ago, is meanwhile more or less over, since probably you have heard about that competition between food and feed, and for sure also the ethical aspects of using such things, where still roughly 1 billion people are hungry on the globe or do not have the the best food what they should have, and therefore the use of those residues and byproducts from the different industries are in our focus to make that products and chemicals out of it what we need more or less in our daily life. So by the way, I have to touch that aspect of the war again when I look to that picture, since we were sitting together with our management board here in the institute exactly that day after the Russia was starting the war more than 2 years ago. And it was really a strange situation sitting in a conference room and talking about those, for us at this moment, important scientific things, but all the time what we didn't know this time for sure, how long does it take, what will happen in the next days, weeks, months, meanwhile years. So this is a picture which reminds me all the time on that horrible day of the beginning of the war. So when we are talking about bioeconomy, most of those activities has to do with the so-called SDGs, what you probably be aware of. So there are 17 different ones, and I do believe that the most important one for all of you in the Ukraine would be at the moment that one, number 16, which is at least in that graph not directly connected with the different, let's say, columns of the sustainability, the socioeconomic, the ecological, and the economic part. But anyway, and I do believe that we could find also some connections to that, which was probably not the focus of that study, what you can see here, and which has been already published in 2019. So if we are talking from the academic or also from the business point of view to those SDGs, I would focus on the number 7, which has to do with the clean energy, which is a huge topic for sure. Then it's about industry, innovation, and infrastructure, number 9. Then it comes to the consumption and production, which should be, in the best case, responsible, number 12. And of course, if we are thinking about all the things what we have to deal with the climate change and to do something to reduce our carbon footprint and things like that, it's closely connected to SDG number 13. So of course we can go also into all the others, but due to the time limit, I guess I'm not going deeper into that. Maybe I will come back to some of the aspects later anyway. So talking about the situation in Germany, as you can see here on the left-hand side, we were already publishing a so-called national research strategy for bioeconomy in 2010. Then it was published a so-called biorefineries roadmap. I'll come back in a second what we mean talking about biorefineries. Then very important step was to release a so-called national policy strategy on bioeconomy, since everybody realized that without the political frame conditions, we cannot go ahead with that ideas, and we need the support of the policy. And then in 2020, in January, more than 4 years ago, a new national bioeconomy strategy has been released, which is not that different from the first one. But as you can imagine here, with all the circles and the connections between the different areas, what you maybe could get an idea what it is about, the microscope for research, something like that for production, agriculture is involved. So just to show that a lot of different areas and aspects are connected closely together, and this is more highlighted in the new bioeconomy strategy. And when I'm, as a biotechnologist today, try to talk about the relation between bioeconomy and biotechnology. Biotechnology for sure is just a part of the bioeconomy. But then we see from that statement here on top that industrial biotechnology is expected to play an important role in this transition from the fossil-based to the bio-based economy in the, hopefully near or mid future, what we are working on very hard. So what is a biorefinery? I like to use this relatively old slide. I guess it's already 20 years old, but it already described this time the idea of changing all the fossil feedstock to the bio feedstock, which are represented here by also different residues and waste material already 20 years ago. And of course, if I am today just talking about the biotech part of that, I will focus on that green highlighted processes here, which are more or less about fermentation. That means the use of microbes, of enzymes, of, let's say, biological systems in general, in order to transform the different feedstocks from the left-hand side to the different products on the right-hand side. And as you can see here, there are so many products what we need. I try to make my, like this, maybe it's better. So the different products, what we could achieve by turning the biomass feedstocks via different conversion processes into the different products. So, and this is what we call a biorefinery, since it's somehow comparable with a classical refinery, which is starting with naphtha or with oil and gas. And the only difference is that we are going to substitute the fossil resources by the biogenic resources. Go ahead. So if we are talking the bio resources, which are mainly represented by that green line of the biomass, we can see here what we would need to feed, in this particular case, the chemical industry in Germany. At the same time, when we are going to use more and more of that renewable carbon, the fossil raw materials will go down. But as you can see here, let's estimate our what we are right now is here, and we have a part of biomass already in those processes. We start to use the plastic waste as a recycling material to feed the industry again. And the biggest hope we all have is the use of CO2. But as you can see here, it will take until, at least 10 years more before the CO2 will be ready for the market. A lot of research is already done on using CO2 for making chemicals and materials out of it. And of course, that would be a very promising approach when we would be able to reduce our CO2 from the atmosphere and use it at the same time for making product out of it. But as showed or announced with that picture, it takes time. It's not a matter of tomorrow. So what are the general aspects of changing the fossil to the renewable feedstocks? So I don't like to read down all or maybe I do that because of the translation, sorry. So it's not a priority list, which is, from 1 to 1, 2, 3, 4, 5, 6, 7, 8. We could do it also in a different order. All the aspects are, in my opinion, in the same level of importance. And again, what you can see here, that slide was already presented 14 years ago, but still, despite so many people are working on this, we are still struggling with the same aspects of quantity and availability of the feedstocks. The feedstocks, the biomass is very complex. We have to do a so-called pre-treatment, since, as an example, if you think about wood, let's say a part of a tree, the stem or things like that, and if we would use that for the chemical industry, of course, we cannot use the tree as it is. We have to break down the structure. First, we have to treat mechanically to make pellets out of it or things like that. So very, very hard work and cost and time consuming. We have, what I already touched briefly, we have to scale it, what we try to do in our institute as well. We have to develop the processes and to optimize for sure. We have, or we should try to use the entire part of the biomass and not only taking this part of the biomass, which is easy to process, and leaving the rest somewhere else. We should try to use everything, and this is what is described by the word cascading use. That means from the highest to the lowest value, and this is not that easy in a lot of cases. So we have to integrate materials into already existing value chains. That has something to do with the processing, with the machineries which are already there for the fossil-based products, and it's hard to convince people in the industry to exchange their hardware just because some people are introducing so-called bio-based products with other properties, with other composition, things like that. So that's very important to do that. The acceptance by customers and consumers, like we all are, is still a challenge, since the people on the street have to know what is behind that idea to use biomass and to make new products, to make the products based on other raw materials. Everything is important to explain to the public. And then, of course, and this could be also on top of the list, the cost of production. If everything what I'm talking about would be already competitive, then I wouldn't need to give you that lecture, since everything would be already in the market, but it is not the case. We are still in the beginning of that transition from the fossil to the bio-based economy, and therefore the cost of production are in the most of the cases still very high, and we have to work on that to bring them down. So if we are talking about that shift of the bio-based economy, you can imagine that we are not talking about a few kilo of a biological substance or things like that. We are talking about millions of tons. And therefore, the question raised why we are not more ahead of that, what we were talking already 20 or 30 years ago. And in that particular paper, some of the reasons have been discussed. So that means the microbes, what I was talking about already, are not already in all cases able to do that, what we like to have from them in order to make the different products in large quantities. So it needs to be an optimization, a development of so-called cell factories to make the job for us. That's the first reason. So the price I already touched with the slide before. The fossil-based products are mainly very cheap, and it's hard to compete with them, since Also, some of the fossil-based products are still subsidized, which makes it much more difficult to compete. In the, I would say, old industry, the dirty one, working with oil, gas, and coal, the facilities are in the most cases fully depreciated since they are working for decades. And a new, let's say, bio-based facility, which would needed to build up on the green from scratch would cost millions of dollars. And without having the market, there's obviously the famous hen and egg problem that on the one hand, the industry is not willing to, let's say, produce something for the market without having already the guarantee that there is something who is buying the product. And this makes it also very complicated. This is what is also described a bit with that bullet point. The growing market is not already there in all cases. And in addition to that, also what we saw not only during the last 2 years was that, limitations of the export of oil and gas. Also in all years, there's a fluctuation in the price of oil. And therefore, it's very hard to predict how the bio-based products could compete with them. So, I don't like to bother you with all the chemistry and microbiology, but just to give you, or those of you who are a bit familiar with chemistry, an idea what we are talking about. There are different studies where so-called bio-based chemical opportunities have been listed in 2004, 20 years ago. Then there was a sort of update of this in 2010. And I just highlighted that 2 organic acids, succinic acid and lactic acid here, since these products are in the focus of my own research, and I give you later a few examples of that. But of course, you will find so many more and other studies about the so-called bio-based chemicals. Here you see an update from 2020. Right now, yesterday or the day before, I saw a similar report from the US where the government presented the research progress and also the already existing products in the market. So if you are interested in that, you can find a lot of sources of information, or in case you like to get something specific, of course, you can also contact me or ask for those information. What is the idea behind? If I come to our own work, you see here again a picture of our pilot plant inside with some examples of the different feedstocks, or in this case, bio waste. It could be kitchen waste, it could be from the industry, it could be from the municipal solid waste, it could be garden waste, different types of waste. And we don't like to burn it, and we don't like to make just compost out of it, since compost is also just water and CO2 once again. We like to use those relatively complicated equipment to make that fermentation process, what I already touched in one of the slides before, and going straight ahead to those chemicals which could be used subsequently in the chemistry to make products like plastics out of it. And this is what is one of the main type of products what a lot of people are working on, the plastics. So again, don't worry, I don't like to discuss with you the metabolic activities of microbes, which is represented here by that scheme, but just to give you an idea about, again, those 2 products, what we are working with is succinic acid and the lactic acid. Besides that, you see here some alcohols, which could serve also as an energy carrier, ethanol, some amino acids. So a lot of different products could be produced by microbes, and especially to that so-called PLA, which is a polymer out of lactic acid, so polylactic acid. There are some outlooks for the market, so but nobody knows if it is or if the numbers will come true. But we are very hard working on this to make it happen. So again, a picture of our pilot plant, what you also see behind me, where we are working on the 4 main steps of such a bioprocess. In the beginning, what I already mentioned, we have to break down the structure of the feedstocks, and since the feedstock could be very different, the treatment technology needs to be very different in some cases. Then after having destroyed the structure of a wood, a straw, a grass, any other fiber, whatever you like, we use the enzymes to hydrolyze the cellulose, for instance, or the starch into the simple sugars, which could be used by the microbes. And this takes place in the fermentation process, where the microbes transform the sugars into the desired chemicals. And here you can see that equipment, what we call consequently fermenter, if I'm talking about fermentation. And this fermenter is containing that raw material which is coming from nature together with our microbes, and here we are making the products. And in the end of that fermentation, we have to do a lot of work of so-called downstream processing to separate and to purify the products out of that more or less dirty liquid which is containing everything. So just to give you an idea what we were working with already, not all parts of the world we already touched with our activities, but a lot. And as you can see here on the bottom, the biggest part of our feedstocks are meanwhile the residues and the byproducts to combine the different advantages, what I already mentioned briefly. So just an idea, we don't need to go line by line through all the different materials, just to give you an idea what we are dealing with and how different the structure of the material is, just from the 3 main components, cellulose, hemicellulose, and lignin. And what I mentioned just a second before is that due to the different composition of the feedstock, we will need also different treatment technologies. This is hopefully illustrated by that tables, since the different compositions require different treatments. And this makes it for sure not that easy compared to oil, gas, and coal. So just an example, I don't go into the details with you, just to give you an idea. This particular example of coffee processing residues, it was a project together with Columbia. Here you see a lab scale fermentation unit. This is a bigger one, 50-liter scale. Then we did all that purification and separation of the product. And in the end, we got the lactic acid, which could be polymerized into polylactic acid. And that would be one example of a so-called value chain from the residue in the beginning to a product at the end. Just another second example from a European project financed by the so-called BBI, the bio-based industries. And here we used the organic fraction of municipal solid waste. That means our waste bin in front of our house. And that could be also used for making a chemical out of it. And despite going into the figures and the different details, just to give you an idea that it could be possible also to use those wastes, which are in the most cases are still burned or disposed somewhere. We could use those materials in our processes. If we are talking about the connection between academia and industry, this national project is a good example for that, since we are working on a so-called innovation circle to bring material into the market, which is in this case, again, that organic acid, which could be used as a so-called building block for bioplastics. Then out of that bioplastics, we can make, of course, a lot of different materials, not only the, let's say, one-way articles, but also technical polymers for long-term applications. Then if it comes to the recycling, we could go for, again, products. And then in the end, if the material is degradable or compostable, we can have a so-called organic recycling, and that goes back to nature, and the soil could be fertilized with those compost, and the new crops could grow again, and the cycle could start and again. So it's, of course, a bit a vision or an optimal description of a value chain, or in this particular case, a value circle, which is not that easy to achieve, but that's the idea behind. So if I was talking already about the scale up, if we like to make all that things bigger, it's not like that funny picture here that we have to make the glasses a bit bigger. That's not that easy. We have to do much more. And for that reason, we built up our pilot plant already in 2006. Again, a few impressions about the size of our building, some lab equipment inside. And again, here you see that fermenter, what I was already showing you before. And at least these two aspects are really important to work on those pilot plants, since we have to develop and optimize those processes, and we have to provide our partners, especially from the industry, with some products, not only in the quantity of a few grams, but in the quantity of a few kilos, liters, to test further and to make the next step of the implementation in the industry. So if I will just announce this, if you are interested in those activities across Europe from the same BBI, what I mentioned right now, there's a map with so-called biorefineries. You know, meanwhile, what it means if we are talking about biorefineries. And we have different colors, the yellow and the green ones. The yellows are so-called demo plants, like our pilot plant, where the technology can be tested, proof of concept, things like that. And then we have the greens, which are not that much, but already some of them, the so-called flagships, which are already producing different products. Now I come back to the title of the talk, if we try to connect academia and business. And in this slide, I just tried to collect some general aspects which are not that typical only for the bioeconomy, but I would say for all types of collaboration between academia and industry. So I just give you the first part of the bullet points, alignment of goals. So you have to ensure that, of course, that what you are doing is beneficiary for both parts and not only one party is the winner of that. Maybe it's obvious, but in some cases, one of the partners try to get the advantage over the other, and this is what we have to to do, I guess. Clear communication for sure is helpful. In some cases, what I also realized in my own career, that in the end, if you didn't communicate that clearly, in the end, it comes to some misunderstandings and some, in the end, your partner was expecting something different because it was not that clearly communicated in the beginning. So try to do that. Of course, it should be the case that all the partners contribute with their own expertise and not just waiting for the others and having, the idea to get, let's say, results, knowledge, know-how from the others. But if you put together your expertise, your project will be much more successful. In this way, of course, IP management plays an important role. So it's not my specific field of expert, but of course, if, for instance, if you have a bilateral agreement with the industry and the industry is interested in such IP, you have to discuss it in advance. And of course, you have also to discuss with your own administration. So resource commitment is important, that you have all the resources you need for that project and not realizing after the half of the project that you...
Буде десь в кінці.
Pardon?
Sorry, it was some hindrance. The participant has turned off the sound, so we can continue. Sorry for interruption.
But you can see my slides all the time.
Oh, of course, yeah.
Okay. So resources are very important, and maybe I have to go a bit quicker because of the time. So despite that, what I was talking before, that a lot of things have to be defined and to set, still there should be some space for flexibility and adaptability, since in a lot of cases was what I realized also, that something changed. The feedstock is a different one. The process has different demands, and you have to be flexible enough to modify your arrangements or agreements. Of course, there's all the time risk management necessary, since again, to that, what is necessary for the flexibility or the reason for flexibility also could influence your strategies to mitigate the risks. And in the end, of course, if you like to go ahead with your partner and try to have a long-term relationship, it should be, trust between the people. That's, in my opinion, the most important aspect. And then it could be a mutual benefit for all of the partners. So that was just very general and had nothing to do with the bioeconomy. But if we are talking particularly about bioeconomy and biotechnology, which is my expertise, then just briefly a summary of that, what we are doing here in my institute, ATB, and what we are not doing is in the bottom of the slide, the green part, which is close to the polymers. We do not do any polymers by ourselves. We do not do any products. We do not make any recycling. We do not do any composting, and we are not, I mean, my group at least, we are not growing up the biomass. Of course, colleagues of mine in the crop department are doing that. Then the blue part is our job, my team of bioconversion. We are making the sugars available for the microbes in the fermentation. Then we have that downstream processing to get out the purified products. And then we can hand over our products to the chemists that they are able to make the polymers out of it. And with that, maybe I can skip that since it's a bit technical and I don't know if it is so interesting for you, very specific, but I like to use that triangle in general in order to explain the connection between the feedstocks, the processing, and the products, what we already saw on one of the very first slides of my talk. And this is all the time that connection what we have to do with. And if it comes then to some challenges or some aspects, what we need to combine the global challenges with the climate change, with the scarcity of resources, with the growth of our population, with the need of other resources for energy and products. And then on the other hand, we have the biomass, the biogenic resources, what we like to use for those processes, but all of them are on a regional level. Yeah, in my opinion, we shouldn't transport, like in the past, the material for thousands of kilometers via a big ship or pipelines, whatever we did in the past for wood, for paper, for whatever, for coal, for gas and oil. We should try to be close to the origin of the feedstock, and this requires quite different things. And I try to summarize this with this slide here. Of course, we have to deal with policy frameworks, and since our challenges are on a global level, we have to take care on national and international levels of policy frameworks. That is, of course, necessary. Not the case so far in all different aspects of the bioeconomy. Then, of course, as a researcher by myself, I'm very excited about technological innovation, which is necessary to further develop and further optimize our processes in order to be more and more competitive with the old industry, with the old products which are already there and very cheap, as I mentioned before. We have to deal with the so-called circular economy principles. You saw during my presentation in a lot of different slides all the time, or in a lot of slides, circles and things which are closely together. And this is what we need to, to go in a right way of ensure the resource efficiency, to minimize the waste generation, and as much as we can to reuse, to recycle, and to valorize those materials, and especially the byproducts, what I was already talking about. If it comes to biomass which is produced, that means not the residues and the waste material. We can have also the forestry as a source of our raw materials. Or we can have crops produced on land which is not, let's say, available for food production, since the soil is very poor and you cannot grow up with corn or wheat or things like that. And you have to grow up some crops which are just for the so-called non-food area. But then you still have to deal with things like deforestation, with destruction of habitats, and of course, biodiversity is a very, very big issue in this sense. We have to optimize our supply chains, which is not that easy with bio resources, since, you know, they are not that stable. They could be spoiled by other microbes. We have to do with transportation. We have to do with logistics like storage. And we have to take care that it is still efficient, even in a small scale, since in some cases we have to collect not millions of tons of a feedstock. Some cases we have just to collect thousands of tons or a few thousand of tons. And this is a completely different story compared with the oil, gas, and coal. And finally, we have to assess all those things with some life cycle assessment to guarantee that all the aspects of sustainability are fulfilled. We have the stakeholder engagement and collaboration between different parts, the government, the industry, the researchers, the public, the civil society, and local communities. And everything needs to be connected to education and awareness. I was talking about that, the acceptance of the customer, and we have to talk to the public what we are doing, why we are doing this, and what could be the achievement and the advantage in the near future. So that needs to be discussed more and more already with the kids in the kindergarten, in the schools, in, of course, the study courses, but also in some, let's say, communication campaigns with the people in the supermarket, for instance. So it's really a big issue. So I'm coming to the end. I just like to share with you some examples of our projects, what we are working or were working with. This was that project where I was showing you the example from the organic fraction of the municipal solid waste. That one just finished last year was something similar with different type of bio waste. And still we are working on two European project dealing with, in this particular case, with wood material, and here with different materials in order to produce nanomaterials for different applications. So in case you like more information about that, you can have access through our websites. And with that, I would like to thank you all for your attention. And I don't know if we still have time for questions, although the time is already close to 1 hour. So it's up to you to ask me further questions or what else. So I was really happy to be with you today, and thank you very much for the invitation.
Thank you very much for your lecture and sharing your experience and expertise. Well, I think we have some time to move to the Q&A section. So I'd like just to ask our participants to leave their questions in the comments, and Lisa will interpret them. But if I may, I would, if you don't mind, I would start. So how does this business and science cooperation work in Germany? I mean, are there any particular institutions, so maybe some platforms that provide bridging scientists and businessmen where they can share their ideas, their project, their demands, or you just have to look for the potential partner, donor, or stakeholder on your own and to apply for the grants? So is there any system? I don't know, because here in Ukraine we do not have such system, unfortunately, and we're working on it.
I mean, we have so many different platforms, not only in Germany, but also on the European level, so-called partnering events, business days where you can go and get in contact to the industry directly. But in my personal case, I would say the most important thing is to be, let's say, present in the community, to talk about that, what you are doing. And in our case, of course, the Institute is closely connected to not only academia, but also to the industry. And we can have joint funded projects with different industrial partners, with different academic institutions, but we also can have direct agreements with the industry where we work exclusively for the industry and they pay for the results in the very end. So depends on the structure of your project. If we are talking about Germany or the academic landscape in Germany, maybe you have heard about Fraunhofer institutes, which are more close to the industry. They have to earn money directly from the industry, which is not the job of our institute. We can actually, in the end, I would say we could do whatever we want. Of course, it's nice to have contacts to the industry, but it's not a must for us. So it's not all of the researchers have to do, let's say, the same job in the same direction. So it's a very diversified landscape, I would say.
Oh, thank you. Thank you. Such a prompt reply. And as far as I can see, we have a few questions already. So Lisa, the floor is yours. Could you please translate them? Lisa?
Joachim, can you hear me? This is the interpreter talking in the English channel. Hi, can you hear me? This is the interpreter talking in the English channel.
Oh,
I just see the last question in English, so I can.
yeah, but you have not heard Lisa, right? No? But you can still hear me, right?
Yeah, you, of course.
It's something, some problems with Zoom. I don't know. We have tested it before. And okay, so let's first ask this question in English. And then I will just turn off the translation and Lisa will join the general channel.
Okay. So cases of contamination. So I mean, of course, if we are dealing with waste or with byproducts from different industries, there are contaminations inside, microbes we do not want to have in our processes. On the other hand, we can expect that if particular microbes are, let's say, living in a waste stream, they are adapted to that situation and maybe they have some special properties, and we try to isolate the different microbes from the different materials. And indeed, we have a collection of microorganisms, not only from the contaminants, but also from our main microbes. So that means we have a collection of about, let's say, 600-700 microbes in our collection where we can start with for doing different processes and different products.
Okay, thank you. So I turn off the translation and we'll all come back to the general session, I guess. Okay, Лесь, ти нас зараз чуєш? Just a sec, I don't know what's wrong. We've been testing it the whole day and everything was fine.
Yeah, you know, this is what I mentioned in my last email 1 hour
Yeah.
ago. We have so many experiences since the corona, but in all or in the most of the meetings, some problems occur.
And every time it's a surprise in what aspect it will appear. So I just probably have to come back to the general. Well, I cannot change anything at the moment. All right, so let's move on as we are, and Joachim, could you please just move to the settings where 3 dots are? Can you see the 3 dots in the right corner in the bottom of the page? Like 3 dots given additional settings.
I don't know what you mean. Sorry.
Okay, it's the lower panel. Can you see the lower panel and 3 dots in the right corner of it? And the bottom of the page. Yeah. Could you please press these 3 buttons, and there is an option translation or interpreting, probably interpreting. Can you see
Okay.
there?
Yeah.
And could you please switch off to Ukrainian channel? There are two channels when you press on interpreting. There are two channels, English and Ukrainian.
And I should mark Ukraine.
Let's mark Ukrainian and we will all appear in one and the same chat. Okay, done? Okay, so I guess we're all here now.
So I was listening to an Ukraine question, but obviously, is it now translated in the chat? So I'm
Yeah,
not
Lisa
familiar.
Lisa will interpret. We are all in one and the same chat, and Lisa will interpret on the same sound channel. So Lisa, can you hear us now? And let's test your voice.
Я говорю в українському каналі, говорю українською мовою. Це з вами розмовляє перекладачка. Чи чути перекладачку?
Да, всім чудилось.
Окей. Ну, якщо пан Йоахім не буде використовувати англійський канал, і ми це робимо в такому загальному форматі, тоді перше запитання я в скороченому, мабуть, вигляді, суто для економії часу, озвучу англійською мовою. So, dear Joachim, we have a question, several questions from...
So I was just hearing Ukraine. Could you please repeat? Maybe I was...
Yep, Joachim, can you hear me now?
Can you hear Lisa now?
Yeah.
Yeah? Okay, so let's listen to Lisa and she will translate again. Lisa, could you please continue?
But if I click English, unfortunately, I cannot hear her. If I click...
Let's say in Ukrainian version. Let's click Ukrainian and stay there.
But if I click Ukraine, I just hear the question in Ukraine, which is impossible.
No, you will hear it in English.
Okay, go
Lisa
ahead.
will interpret it. Okay.
This is the interpreter talking. Can you hear my voice?
Yeah,
Here I am.
now
Okay,
it
good.
works.
So there are a couple of questions in the chat.
Yeah.
The first one of those is about the cost, the first cost of the raw material that you use, and that your biorefinery at your institute produces compared to the raw materials that have been produced with the help of traditional technologies. So what you produce, what is the cost of that compared to the raw materials that would be produced based on traditional technologies? And so another part of this question is, your raw material, the one which you produce at your biorefinery at the institute, can it compete market-wise when we are talking about the raw materials used in the chemical industry?
Yeah, of course. Of course, yeah.
Sorry, Joachim, could I ask you to make some pauses here because Lisa will have to translate step by step as we have lost our channel. Thank you.
Okay, of course, we cannot compete at the moment. And what we try to do with that waste and byproducts is, in the best case, those materials have a so-called negative value. You know, if an industry is producing a byproduct and they would need to pay for the disposal of that, that would be a negative value. But in a lot of cases, meanwhile, since also the byproducts and residues has so many opportunities to get valorized into different products, therefore the negative value is not so often the case, and I cannot give you any figures about that since we are just doing research. We are not selling our product.
Yeah.
Переклад українська. So this is going to take some time. Joachim, please bear with us. I'm going to consecutively translate what you've said in English into Ukrainian now. Відповідь на запитання. Ні, ми не є конкурентними. Що ми намагаємося робити, коли ми використовуємо відходи і різні біопродукти, то це, власне, взяти те, що має, по суті, негативну вартість. Тобто, скажімо, є певне виробництво, є певна промисловість, і побічним відходом, залишком від цієї промисловості буде певна біопродукція. Якщо такій промисловості потрібно платити за утилізацію того, що для них, по суті, є відходами, то ми говоримо про негативну вартість. Натомість, якщо подивитися на те, що робимо ми, то ми, власне, намагаємося використати ці біовідходи, ці залишки таким чином, аби їх валоризувати, надати їм певну цінність, бо ми показуємо, що з них можна виробити певні продукти. Але я не можу тут навести вам якісь конкретні цифри або факти, бо, по суті, ми є інститутом дослідницьким, ми не займаємося безпосередньо тим, щоб продавати вироблене нами економічною діяльністю.
Okay, Lisa. What about the other questions?
Right. And also there is a second question, which is also in Ukrainian, and it's about the perspectives of using microbiological substances for soil application. Sorry, give me just 1 second. Based on the properties of beneficial soil bacteria.
That's not my own field of expertise, but in my department, we are working on the so-called microbiome biotechnology for different applications. It starts at the soil, it goes ahead with the crops, it goes ahead with the human nutrition, going back the residues to the field. So that circle, or what we call the so-called One Health, the environment, the animals, and the humans should be in a good balance in view of that microbiome. But it's not my own expertise.
Це не безпосередньо те, чим займаюся я, хоча це напрямок, з яким працює мій факультет, який працює над технологіями, пов'язаними із мікробіомами. Тобто загальна ідея, і ці технології можуть застосовуватися по-різному, загальна ідея полягає в тому, аби пов'язати між собою в один ланцюжок, в одну схему вирощування врожаїв різних зернових, наприклад, культур для харчування, відповідно, виробництво продуктів їжі для харчування людини, повернення знову через, наприклад, удобрення, компостування цих поживних речовин назад у поле, у ґрунт і так далі. Тобто ідея загальна полягає в тому, аби збалансувати існування навколишнього середовища, тварин, людей, або воно перебувало в гармонії. Але, знову ж таки, не конкретно напрямок моєї діяльності як дослідника.
Thank you, Lisa. There is one more question. We have skipped it. It's about the biotechnology. And the question is whether the biotechnology can suggest any solutions about the problem of the microplastics in the environment and its harmful influence and so on.
Yeah, therefore, when I'm talking about bioplastic, maybe you know that definition of bioplastic could be whether based on biogenic material or could be biodegradable. And the biodegradable part of the bioplastics, of course, are very important if the plastic is in some closely connection to the environment. If we would have, for instance, a bioplastic in your car, it has nothing to do with microplastic besides of the rubber of the tire, you know, but if we are making long life products, then it is not a matter of bioplastic. We have to take care on the packaging, especially, and therefore we are developing those biodegradable plastic.
Thank you.
Joachim, can I briefly ask you to clarify? So what you were saying, if I could repeat it back to you to confirm whether I understood you correctly, is that you would differentiate between different kinds of users, right? The idea is for bioplastics to be made from biogenic materials or to be biodegradable. And when we are talking about biodegradable plastics, we can again think of different possible uses and applications. For example, there is a possibility of using bioplastics in car tires, and this is nothing to do with microplastics, for example, and they use, and then there are other solutions, like, for example, packaging, which is made from biodegradable plastics. How much of that is correct? Did I understand you correctly or not?
Yeah, it was a perfect summary, since that's my main message in all those discussions. Everything depends on the application. Yeah. If we are talking about agriculture, to have such mulch films on the field, and if you make that mulch film biodegradable, then the farmer doesn't need to remove the film, clean it up and use it again, or have to do something as a disposal, since it's not degradable. So if we could have applications where it makes sense to have biodegradable material, then we should do that. But if not, for instance, if we are sitting in front of our computers, all we are here, and a lot of parts of the computer is out of plastic. But if you go to the forest or somewhere in the nature, I am asking especially the young people, did you find yesterday during your walk in the forest one piece of computer or one piece of smartphone or things like that? For sure not, or only in in very rare cases. So we don't need to have biodegradable plastic in our computer, but it should be bio-based. Bio-based means that we go from the fossil-based to the bio-based raw materials, and to save that fossil CO2 and to protect the climate. This is the main information behind.
Can I compress this a bit for the sake of brevity and time? Can you give me permission to do that, please?
Pardon?
Can I compress your answer a bit for the sake of brevity and time? Can I ask your permission to do this, please?
Yeah.
Thank you. Я трошки в скороченому вигляді дам відповідь Йоахіма, і, можливо, певні її частини трохи переставляючи місцями, але відповідь в будь-якому випадку була. Це залежить від призначення і конкретного використання. Чи говоримо ми про біопластик і його використання, чи говоримо ми про біогенні матеріали, щось вироблене на основі біогенних матеріалів. Тобто ми можемо уявити собі тут різні варіанти застосування різних речовин та матеріалів. Наприклад, чи, скажімо, використовується якийсь матеріал для виробництва шини у нашій машині чи якогось іншого елементу. Чи, наприклад, ми говоримо про потенційне використання, скажімо, певного матеріалу у пакуванні. Або, скажімо, якщо ми думаємо про сільське господарство і про те, що є сенс там використовувати біорозкладні матеріали, речовини для того, аби не потрібно було додатково витрачати кошти, але також забруднювати екологію вивезенням, утилізацією і так далі, того, що не є біорозкладним. Приклад, який я наводжу, за словами Йоахіма, коли я говорю зі своїми студентами, молодими людьми загалом, бо я фокусуюся на цьому у своїй роботі. Це нам завжди потрібно думати про те, як ми застосовуємо певну речовину. Скажімо, якщо ви сидите перед комп'ютером, то зрозуміло, що перед вами буде пластик, але це не будуть якісь біорозкладні речовини. З іншого боку, якщо ви йдете по лісу, то ви навряд чи в цьому лісі знаходите там якісь елементи комп'ютера або смартфона, тобто це не відбувається, хіба що в якихось дуже рідкісних випадках ви на ці елементи натрапите. Тобто зрозуміло, що в комп'ютері ви не будете використовувати біорозкладні матеріали, але бажано при цьому було би використовувати ті, які є все ж таки біогенними, біоматеріали, таким чином зменшуючи використання викопного палива, зменшуючи, мінімізуючи викиди діоксиду вуглецю і дбаючи про клімат.
Yeah, sorry, I just forgot to turn on the sound again. So thank you, Lisa. Thank you, Joachim, for joining us. And on behalf of all of us, I want to thank you and to thank your country and the citizens of your country for what you're doing for Ukraine and for supporting us on this eve. Thanks a lot, and I hope one day we'll meet in person,
Yeah,
either
that
in
would be
Germany
great.
or in Ukraine. Yeah.
Thank you very much, and all the best to you all. Thank you.
Thank you.
Thank you.
Так. Дорогі учасники, маємо перерву в 40 хвилин. А потім чекаю вас, якщо у вас ще вистачить наснаги на зустрічі з пані Маргаритою Бримаседою, де ми продовжимо.
Дякую, до зустрічі.
Дякуємо, та до зустрічі.
Дякую.
Дякуємо, дякую.
Thank you very much.
Thank you.
Thank you.
Ciao.
Goodbye. Thank you. Have a nice evening.
Yeah, you
Keep
too.
care and carry on.
Bye.